My name's Donald Christensen. I'm in the BE program.
Okay, and?
My name is David Warnica. I'm also in the BE program.
Okay, we're here at Fall 2014 Open House, and we got a project going on here, so I'll let you go ahead and describe it.
Yes. So pretty much our project is a Conformal Code automated optical inspection system, and pretty much what that does, all that's going to be doing, is there's going to be sometimes when you manufacture PCBs, manufacturers will apply coating on it to protect parts from harsh environments and things like that for military reasons and so on and so forth. But anyway, right, what we're doing is we're taking this camera down here, taking this camera that's attached to that robotic arm that's all under UV light, and we are looking at the coating on the parts and seeing where there would be quote-unquote defects. So, like right here, for example, I have a couple of defect sample. This coupon in the middle right here, this is what the entire board and all the parts should look like. And over here on the left, this is a little light. The thickness isn't as much, and that would be considered a defect. And over here, that may be hard to see, but there's actually little white spots, and those little white spots are actually bubbles.
Okay.
That would be considered bad.
Yes, and that would be considered bad. And usually you'll find those on like solder joints or traces, things like that, and you actually have to remove. And the camera over here is actually going to look for all those defects and let the user know, and actually save those pictures and let the user know where those defects are on the PCB.
So this is the image from the camera underneath the table.
This is the image from the camera underneath, and with the press of the button, it's actually going to move and actually inspect all the different parts, and everything that's shaded white will be considered a bad area. And the board we're using has a lot more bad areas than usual, and that's just to show that okay, it's working.
Demonstration purposes.
Yeah, for demonstration purposes, as opposed to something like this, where all the coating's nice and conformal, and all the parts have been touched up, and
Awesome. So what's all the circuit board stuff that you have going on here?
All these circuit boards. There's a lot of. Well, we weren't given a controller for a robot, or we didn't have a controller or a PLC available. So what we did is we took the HC12 board, the microcontroller here, and we used that to send signals to different motors, and we're basically using it to control the robotic movements. So we have a bunch of timer circuits that are going to set a length of time that send the signal, because we couldn't use the pulse modulation on the HC12 because it doesn't draw enough current for that. So we actually had to use these power supplies and timer circuits, and depending on our RC network, we'll be able to change the amount of time to move in certain positions, and then we code all of that with the C program here. All this coding is pretty much for.
It tells it to move left when we tell it to move left. It moves right when we tell it to move right.
Okay, awesome.
Up and down, Now for this project, we only had a few axes hooked up to the robot because that's all we needed for what we were doing. When we actually do our senior project, we're hoping to snatch a controller from someone else because everything else will be done, and then we'll just use that for our senior project. But for temporary purposes, this works just fine.
Yep. Okay. Terrific. All right. Looks good. So this will be like hands for spring open house probably, and you have more components.
This should be done in December.
Oh, you're going to be done in December. Okay.
Yes.
So in December we'll take another look at it then.
Yes.
Okay. Awesome. All right. Good job.